Would be today or now is about when we talk about free fall objects and objects falling from a certain height. How do we know or how do we measure how fast this object is falling? So we know that what's affecting this is gravity and only gravity, right? But what if we think about two different objects with two different masses? Now, I know there will be assignments on discussion and an explore activity on Twig and another worksheet that will, and this will be kind of wrapping up what you guys have done in the explore activity. But what if we talk about masses? How do I know if the object is, does that mean if the object is heavier, that means it's gonna fall faster? Or like if we put an elephant and a mouse and we drop both of them off from a certain same height, does that mean the elephant will go down faster because the elephant is heavier? Or does that mean that the mouse is gonna hit the ground fast because it's lighter and it's speeding? So this question is probably one of the important observations that you've discovered when you were reading through Twig or when you were doing the explore activity. But the answer is, it is absolutely wrong. The mass has nothing to do, well, it has something to do, it's an effect, but it's not the only thing that would really affect which one is gonna go faster. Because remember that free fall is it's under the influence of gravity. They do not encounter a resistance. All right. So they will only, more massive object or the heavier the object is, they will only fall faster if there is an enough amount of air resistance and presence. So let's just write elephant or mouse. So I'm just gonna sum up what I just said. So the two objects can travel at different rates they travel at different rates. What else are we gonna say? Free fall is the motion of objects under the influence, under the sole influence of gravity free fall objects do not encounter air resistance. So which means, in other words, that more massive objects will only fall faster if there is an amount of air resistance present. Okay, we're going to talk more about this and how to find the value of, how fast things are going or how long did it take them to get there once we get to the next unit. Okay, so what I'm going to say, the actual explanation is that so why it doesn't matter how heavy the object is. The real explanation would be it's because here the actual explanation, let's do this. Of why all objects accelerates at the same rate involves the concept of force and mass. So, in other words, I can say the equation is F is equivalent to the mass times acceleration. So we got the force, we got the mass, and we have the acceleration. Okay? All right, so in this unit we talked about and we described, we talked about velocity, speed, distance, displacement, acceleration, gravity. So now we're gonna describe all these motions that we've learned about in 4 important equations. We call them the kinematic equations. So, and these are equations that you have to memorize. Okay, so what does it mean when we talked about displacement, and we said in displacement, we talk about direction of the object, we care about the magnitude, so whether it's plus or minus, while as the distance, we're just adding up like all the distance, we don't care about direction. Time is time. Accelerate. When we talk about acceleration, we're talking about if it's free fall, we're talking about gravity, 9.8 meter per second square. If we're not talking about free fall bodies, then it's just the velocity, and we're gonna see how we're gonna find the velocity using the formula: distance equals velocity times time. So let's talk about the 4 important equations that describes motion. The 4 kinematic equations that describe an object's motion are, so you have to memorize them. I'm just going to write first one, d equal vi, the initial velocity, times t plus half acceleration times t squared. You know what, I'm just going to put here 1 so that you don't get confused. Second equation would be the final velocity is equivalent to the initial velocity plus acceleration times time. And then we got final velocity squared is equal to the initial velocity squared plus 2 times acceleration times the distance. And then you get the distance, which is v initial minus v final, plus v final, which is the average velocity, over 2 times, all this is times t, which is the same as distance equal v times t, but this time we're taking the average velocity. All right, I'm just going to say what does each one stand for, and I'm going to end it here because I'm going to have a worksheet that we're going to be working on. For examples, let's do D is your displacement. So that is D. A is your acceleration. Let me do this. That D is in meters. Acceleration is a meter per second squared. That is your A. V, I is your initial velocity, which most of the time your initial velocity is 0. Like you always start at 0 speed, right? So that's your VI. All right, now VF, VF. Oh, and here the unit is meter per second. VF is your final velocity. And this would be measured in meter per second as well. And we get T, and T will be your time that is measured in seconds. I know there is a lot of formulas here, but once you get to know how to use them and put your given, it's not going to be hard. So it's going to be time in seconds. And then in the next video, we will go ahead and start applying these formulas to real-world examples and problems so that we see which one we can use and how we apply them. All right.